Okay, let's start. I will make introduction of the new open source project Quasar. It's an efficient multi-sandbox container runtime. As we said before, as the other two the other two said that we have integrated the Quark or WebAssembly or the micro VM sandboxer into this. So it's a multi-sandbox container runtime, and they will make introduction of it. So I will first I will give a history of talk about the history of the sandboxing container. Actually, in the early days, there's no such a thing as a sandbox in Docker. But Kubernetes has a notion of pod. They can run multiple containers in a pod. So they need such a thing as a sandbox. So in the early days, Kubernetes create a pod container and use this environment as a sandbox for running all the containers in the same pod. I think that's a compromised way, but it can make it work. And but in this way, because Docker has to start a shim process for every container, so you will see many shim process running on the host of running the containers. It's of course a memory overhead, and it will affect this startup latency too. Here comes to the stage two, the shimv2. Actually, the shimv2 is pushed from the Kata containers to the container D because in the early days, the Kata containers have many processes running on the host. It's even more than the containers running for runc, because they have so-called the Kata proxy or Kata shim, and every container has a Kata shim process. So there are almost more than 4 or 5 processes running on the host for one pod. So they want to reduce this, and then they made this shim v2. They upgrade the shim API and pushed it to container D. So for the shim v2, although the Kubernetes still creates a post container as a sandbox, but it will annotate it as a sandbox container, the so-called sandbox container. And in the shim process, it will determine if the created container is a sandbox container, and if it is a sandbox container, it will create a shim process. So it only create a shim process for one shim process for one sandbox. That reduces many processes. So we can see that for Kata, that you just need only one shim process for each port, and they do all the things that of Kata proxy or the Kata shim before. And this is also brings the benefit for the runc containers too. They also just need to start one process, the shimv2 process for the run a Kubernetes pod. But in this way, the container and the sandbox management, the APIs are messed up in one set of the API. I mean, there's no such thing as a sandbox API. So especially in Kata, they just for example, the virtual machine management, or if the Kata want to do some resource hot plug, these actually are the management about the sandbox, but they are messed up in the task. So so here comes the third stage, that someone proposed the sandbox API to container D, and this is actually along with the background that more isolation technologies come into the container world. For example, we have the Kata containers, which is implemented in micro VM, and we have the wasm edge or wasm time with WebAssembly, and app kernel and unikernel and confidential computing. All these isolation technologies are connecting to the container world. So this makes Sandbox become more and more important. In this background, that the Sandbox API is proposed, and this makes the Sandbox the first class citizen in container. Then this makes first it removes the so-called post container. It makes a history because sandbox management. They don't actually, if we have sandbox APIs, they don't need this post container anymore. And the sandbox management is no more mixed into the task API, because we have the sandbox API. Although it split this sandbox API and task API, but actually currently it is still actually the shim process is still the carrier of the sandbox manipulation. So it's still this shim process to provide the sandbox API, and because we need a shim process for every sandbox or port. So it's still there were still a lot of shim process running on the host. Although we know that it is for doing the port lifecycle management, or do the restart recovery, but I think we can have some way to do it, and to reduce this shim process. So we want to make some better way to do this, and before we are doing this doing the improvement, we want to make a clear definition of a sandbox. So we are thinking what a sandbox is, what a ideal sandbox it is. So so this is our definition of a sandbox. It's I think it's an environment, isolated environment to run containers in it. This definition, I think, is abstract. So we add some supplement. First, I think it can be a black box. So for the sandbox, so it can be a black box for Canary or ISO-ID, so that the Canary or ISO-ID do not need to care about if there is a shim process, or what kind of files it need to start containers in it. They just don't need it. What they need to know, that it's a black box, and it will expose the task API to it. So the container D, or is just call the task API through some address. In this way, that because it's abstract, so we can implement it in a highly integrated way. I mean, maybe we can just start one process. For example, for the virtual machine, we just need to start a QEMU process or hypervisor process as a sandbox, and maybe one thread is enough for start a sandbox. So it can be highly integrated. And the last one is that as a sandbox is something running, so everything is running inside the sandbox itself. So the sandbox itself cannot manage the life cycle or resources itself, because all the things are running inside the sandbox. They don't know the resources outside. So we need something else outside to do the management. That's actually what we want to make. This is called the sandboxer, and it will implement the sandbox API, and it do the life cycle and the resource management for all the sandboxes in one kind, running on host. So here comes the Quasar. That's what we already open sourced it, and provided different kinds of the sandboxers. First, we did some change of the sandbox plugin in Canary or and ISO-ID, and to support calling the new sandbox API that we changed. And we made a Rust sandbox library for the common logic, and build the concrete sandboxes on it. We already implemented 3 kinds of sandboxes. It's a micro VM, Quark, and the WebAssembly, and all these sandboxes are implemented in a highly integrated way. It just actually we have implemented that it's one process for each sandbox. So it's all implemented without the shim process, and the task API server are running inside this process. And then I will introduce individually of these three sandboxes. First one, the micro VM. It's actually we can compare it with the Kata containers. This architecture with the Kata containers. We can see that a sandbox is a virtual machine process running inside the namespace. It's just one process, and the task API server, which is for the container management, is running inside the virtual machine as a PIP1 process, and it will. The Kennedy can call this task API through the virtual resolve to the task API server inside the virtual machine. And as the virtual machine is running, the other process is running inside the virtual machine, so we need a sandbox process running outside on the host to do the management, as we said. This VM sandbox implemented the sandbox API and configured it as a proxy plugin into the Kennedy or Israeli. And when Kennedy want to do the sandbox management, they call the sandbox API to this process. And for the virtual machine, just what we do is to call the to start a virtual machine or to do the resource hot plug or unplug. And the IO are redirected out from a serial port or even a vSock to directly into the container D. That's also what we implemented. And then we get this app kernel sandbox. Actually, Yulin has made some introduction to it before, and this it's also a one process for sandbox. It's a Kuasar process, and it will run a kernel inside this process. And this process will start a task API server inside it and serve the task API through a unit storm socket, and container D can call it, call this call API through this socket, and it will start the containers inside the kernel that inside this process. And for this, in this scenario, the Quark sandbox, what Quark sandbox do is it's not that that many as the micro VM sandbox, because you just need to launch this process and maybe do some bind mount of the folders or directories or some files. And and as it's just a process, so the container IOs can be redirected out through the naming pipe. We just need to bind mount the name pipe to the namespace, and then Kuasar or kernel can recognize it. And the third one is the WASM WebAssembly sandbox. It is also mentioned before by Michael, and this maybe we can make it more lightweight, because for the WebAssembly, the startup latency is most important. So recently we implemented by forking a new process to as a WASM runtime to run the container inside it. But actually, maybe if the WASM resolve the problem that they cannot redirect this SDDIO, maybe we can just start the WASM runtime inside the process itself, and so all the things are running inside the process. That's actually a pattern of one of the pattern of the Run WASI project do. So because I think for the WebAssembly containers or WebAssembly apps, they the restart or the availability is not that important comparing with this startup latency. So maybe we can make it one process to run all the containers. So these are the three sandboxes that Quasar provided. And we did some performance of the Quasar micro VM and compare it with the Kata containers. We can see that with this new architecture, the performance can improve very much. And we did two tests. First is the parallel startup time, and we can see that for the Quasar micro VM, all of the 50 ports start parallelly. The startup time can be less than 1 second, but for Kata containers, it's about 1.7 seconds. So we can say that it's a big improvement. And it also we can also see that it can reduce the memory overhead of about 1 GB for 50 ports running on a node. I think this is important for the IoT devices because or some memory restriction environment, because the memory is restricted. So we can say the 1 GB memory is also it's also a big save of the memory. And then I'd like to introduce some future works of what we want to about the Quasar. First, we want to make the sandbox API specification. Maybe we can push it to the OCI community. I think we can make this sandbox API a standard of container. And then we have to say that the Quasar is in a preliminary stage, and we need to add more features into it. For example, we need to add some CLI tools, or we need to enhance the maintenance and the security. And also we need to add more support of technologies like Runtime and Firecracker, the VM, and or we need to support the running on the ARM architecture, and that's because if we want to make it on some edge computing scenario, we need to make it support on ARM. And the last one, I think it's also important that we need to support the confidential sandbox, because I think it's becoming much popular. And actually, I think in the future, maybe more customers would like to run their containers or run their applications in the public cloud in this way. So maybe it's also a very important thing that we have to do in the future. And this is our this is our website of project. So anyone is interested in this, or want to add more the other features to it, can submit the issue or PRs in this project. So that's all that I did, and any questions is welcome.